Hello, this is TediAnne here, and I want to help you understand an essential concept in using data. That concept is called scales of measurement. It helps us connect data with the concepts we're trying to measure. And why is the concept of scales of measurement essential? Well, I have 4 good reasons. First, we need to recognize that measuring assumes that there is a phenomena of interest that we're attempting to study. Phenomena have natural properties. We want to select a way to measure those properties in an appropriate manner. For example, physical gender. It has natural properties. There are no properties regarding physical gender that are hierarchical or have a magnitude of difference. There is no absolute zero in the phenomenon of physical gender. You can't have no gender at all. Gender is a phenomena of nominal properties, so it's measured with a nominal scale. If we don't measure a phenomenon in the right scale, we generate data, but that data is garbage. You could create a rank order scale of physical gender, assigning male a value of 1 and female a value of 2, and pretend that 2 is greater than 1, but that is simply not true when you think about the idea or the phenomena of physical gender. Fourthly, programs like SPSS and Excel, they will work with whatever data you put into them, and they will crank out results. But the fact of the matter is those results will be garbage. Unless you understand scales of measurement, you won't be able to recognize that the output that you've gotten from these wonderful computer programs is garbage. So let's talk about this idea of scales of measurement. There really are just 4 scales of measurement because phenomena that exist fits into these 4 types. And we're going to take a look at each one of these 4 types so that you are solid in your understanding of how this works. Those 4 types are nominal scales of measurement, ordinal, interval, and ratio. Let's look at nominally existing phenomena and how we measure it with a nominal scale. When we say that something is nominal, we're saying that the phenomena exists and it is just categorical. There's no inherent numerical properties in the phenomena. I used a minute ago the idea of gender, but also your place of birth or the type of car you drive really is simply a nominal phenomena. You can only label it. It really doesn't have any order of magnitude. Now, we would measure these types of phenomena by simply assigning a code. But you don't assign any magnitude to that code. A 1 is just a label and could be as easily replaced with a hashtag or a smiley face. So you need to be careful when coding nominal data that we don't give undue meaning to letters or numbers, assuming that an A means something better than a B. Now I'm talking about nominally scaled data and not your grades. Now let's talk about ordinal. Ordinal is the term that we use for phenomena that exists that has an inherent magnitude to it. But the magnitude is not equal across all the options that you can use to examine that phenomena. An example of that is anything that can be rank ordered. Olympic medals, when they are awarded in gold, silver, and bronze. But there's no magnitude between the difference in performance between a gold medal and a silver medal performer. But they are simply the gold medal performer is better than the silver medal performer. The same is true actually with the grade that you have in school. Being in first grade is not as advanced as being in second grade Second grade is not as advanced as being in third grade, but there is no even distance between being in first grade and second grade and third grade. Even though we think it is, it really isn't. Another example of ordinal scaling that's used quite a bit in certainly in consumer research is the idea of liking. We create a Likert scale and we ask people to rate how much they like something, from don't like it at all to like it a lot, and maybe the midpoint is a neutral. And we pretend as if we're measuring some phenomena that has neatly intervaled differences between don't like a little, like somewhat, don't know, and whatever. But we really don't. There's not a real true order of difference in these different intervals. And the same is true with the idea of satisfaction or appeal or any number of attitudinal concepts that we might want to measure. The third way that we measure phenomena, or the third type of scaling that you would see in a phenomena, is what we call interval. Interval is when a phenomenon exists that have inherent properties in it of magnitude and equal interval between the points that can be measured and can be given a numerical value. Examples of this are a Celsius temperature scale. A Celsius temperature scale has been scaled so that the idea of water freezing, which is an actual physical property, happens at a point that's been called 0. And when water boils, that point has been called 100. And then they've divided up the temperature difference between water freezing and water boiling equally across 100 points. So we have two discernible physical properties, freezing and boiling, and then an equal distribution of the temperature change across the scale. Another example is how we measure time. We know that we can construct a concept of time that breaks time into equal intervals, seconds, minutes, hours, and days. Things get a little messed up when we start doing months just because we're trying to peg it to a solar calendar or a lunar calendar, but that's getting to someplace else. Now, I want to go back to the idea of temperature and ask the question, is a Fahrenheit scale an interval scale? It has all these equal little measurements across the thermometer. For example, when you're measuring your child's temperature, when you think the little one has a fever. But is it an interval scale? Actually, a Fahrenheit scale is an ordinal scale. It is not an interval scale because the magnitude of difference between the points is not equal. And we really see that in Minnesota. For those of you that live up here in the tundra, the difference between 0 degrees Fahrenheit and 30 degrees Fahrenheit is not the same difference as you would experience between 30 degrees Fahrenheit and 60 degrees Fahrenheit, despite the fact that both those differences have been measured as just 30 degrees. The fourth and final way that we look at phenomena to be able to measure its properties is what we call a ratio scale. And a ratio scale is measuring phenomena that exists that has inherent properties of magnitude, of equal intervals between the points that can be measured, and has an absolute 0. So there is a physical property where there really can be none of it. A great example is income. Income is racially scaled because we know that it's possible to have absolutely no income, a big fat goose egg 0. We also know that when we measure income in dollars, we're measuring it in equal intervals. And we also know that $1,000 is more than $1. And so it has all the properties necessary to be able to scale it in a ratio way. Another example is our age. There is in our society, we use a birth date, a day in which a child has come out of the womb, as the 0. and begin counting a person's age from that point in time in regular intervals. We call them days, or we could even take it down to minutes or seconds. When we want to measure temperature, and we need to have, for scientific and physical reasons, an absolute zero, we use what's called a Kelvin scale that allows the concept of something having no temperature at all, an absolute zero, be a part of the calculations. Now, I know nothing about physics, so don't ask me to explain any more than just that. So, here are some considerations that we need to take into our thinking when we're seeking to measure a phenomenon. First is that you have to recognize that you can attach meaningless numbers to anything. I can say female is 2 and male is 1. And that works just fine if I'm only using 1 and 2 to label something. It means nothing if I'm saying that 2 is twice as good, or twice as wonderful, or twice as amazing as 1. The other thing you need to consider is that analysis programs like SPSS and Excel will manipulate those numbers. If you put in numbers about gender and say that all females get a 2 and all males get a 1, I guarantee you that SPS will give you an average number, and you will get an average number of gender. There is no such thing as average gender. It's a concept that doesn't exist. But SPSS will give you an average, and so will Excel. You also have to remember that these programs will spit out output. And as a matter of fact, that output will be garbage. So you have to attend to these things so that you don't end up looking at output from computer programs and say, oh, this has wonderful meaning, and discover that you're working with stuff that's pure gobbledygook. I hope it's clear in this short little lecture that how we measure something must absolutely match the phenomena itself, the physical properties of the phenomena. If something is naturally ratio, then any scale will work. But scales will lose their power if you're not using a ratio scale. If something is naturally an interval scale, that there is equal distance between occurrences of the phenomena, then you can use an interval scale, and an ordinal and nominal scales will also work, but you'll lose a little bit of computing power. If something is naturally ordinal, that there is a natural hierarchy within the phenomena, that there you can say greater than or less than, you can use an ordinal scale or you can use a nominal scale. But if you use a nominal scale, you're going to lose computing power. And so now let's apply this to TediAnne's age. Let's say that you are supposed to measure TediAnne's age. Now, there's a whole bunch of ways you could go about doing that. You could look at her, and you can use a nominal scale and say, all right, she's not dead, and she's still aging. So there are 2 nominal labels that we can use to describe TediAnne's age. Not dead, still aging. You can guess at her age. You can use an ordinal scale, and you can say, all right, she's young, or she's old, or she's very old. And that would be using an ordinal scale. You could ask her via a survey using either an ordinal or interval scale. You could say, is your age above or below 40? Is your age above or below 50? Is your age above or below 60? That would be using an ordinal scale. Or you could use an interval scale and say, check the box. In what category is your age? And this is often how surveys will use age, and it's not a good way to do it, but it's an easy way to do it. Is your age between 19 and 30? 31 and 40, et cetera, et cetera. So you could ask her to fill out an intervally scaled survey question. You could ask her for a number. You could say, TediAnne, tell us how old you are. And that would be a ratio scale because we have said in our society, age is counted from exit from the womb, which is 0. You could ask her birth date, but actually a birth date is a ratio scale. Can you think about why that might be? You could also ask her for her birth certificate, and that would likely give you a ratio scaled data that is the most accurate. Why? Because they don't lie on birth certificates. How you choose to measure a phenomenon? Well, you need to look at its natural properties. You have to ask what type of measurement instrument is going to be used. You want to discern your degree of precision, because sometimes you don't need to measure things as perfectly as a ratio scale would give you. Something lesser than that will work out just fine. You need to discern, is the data even available? Can I actually measure something the way that I want to? Because sometimes we can't. And then the important aspect is, how are you going to use the data in your analysis? Let me explain that. Your analysis plan is a very important factor in all of this. You want to measure phenomena in accordance with its natural properties and your analysis needs. A great example of that is age. A lot of times in survey work that I've seen, the researchers will collect age in an interval scale, or worse, in an ordinal scale. They'll just look at age being, older or younger than something. And what happens is then they try to do some comparisons, in particular using regression or other statistical techniques that require having a mean. And you can't do it because you can't calculate means from anything other than interval or ratio data. So if your analysis plan includes doing any kind of statistical testing that will require a mean or an average, you have to figure out how to measure that phenomena with an interval or a ratio scale, or you have to measure some other construct to get at the same idea. So as you look at this table, you can see that if you're going to use a mode or just counts or just frequencies, then any of those scales of measurement are going to work for you. If you're comfortable using just medians or ranges or a hierarchy, then the only thing that doesn't work is nominal. The other scales will work just fine for you. But if you want to look at the more robust ways that we do statistical analysis, look at means, look at variances, or look at standard deviations, which are all a part of the statistical testing that we use, then you need to have data that is either interval or ratio. Well, I hope that all helps. And so now let's look back at the concept of TediAnne's age. By the way, how old am I? Well, let me give you some data. Besides just looking at me, and let's hope that doesn't peg me to some place much older than I really am, I graduated from high school in 1975. So does that date help peg how old I am? Well, it might if I didn't graduate from high school when I was 12 years old, or if I was one of those real late bloomers and didn't graduate from high school until I was 22. You might ask me how old I am, and because I'm a good Bethel instructor, I probably won't lie to you, but I certainly could. So that might not be the most reliable way. So probably the most reliable way to measure my age is to do the ratio scale, go get my birth certificate, and find out that I was born in 1957. You do the math. Hope this all helped you better understand scales of measurement, and I look forward to continuing working with you through this course. Thank you.